Hello, and in this video I'm going to show you how we can get some more interactability between a baked particle and a Niagara particle. The project that we will build will be this Lego pad, so when a player walks close to this particle, it will automatically build the Lego pad. Now to get started, we are going to here in Houdini create that version. So here you see a version of that, and it all starts with a curve. So this will be my base curve of where I would like to have this thing. Then I will add some sweep, and I will also use the torus shape. So we have here my base pad and some of these rings there. So you can play around with some basic shapes, and it will automatically then convert it into Lego bricks. Then also here very useful is the points from volume. So I will convert the geometry back into points. So they are evenly scattered out based on a grid. And I will also here with the transform squeeze them so they are in a good position for when I copy a Lego model on them. Then after that, I'm going to create an attribute random. And here I will create a random value from 0 to 5. And it's set to uniform discrete, so we only get integers. So here we are either getting 0 between 5 value. Now from that I'm going to color my points. As you can see here, they all have a color, and I will use the color node, and I'm going to use color with ramp, and I'm going to use that with the index. So here I can fill in these very colorful colors that will represent my color for my Lego bricks. Then further down here, I will add some attributes to sort of like fake some of the data that we need for particle information, like a time, ID, and lifetime. So we can just set that here in a wrangle. Now next, I would like to sort of calculate a random area. So we can calculate this in Houdini as well. So here I scattered these points around. So what I did is I took my curve from the beginning, and in there, basically sweeping that curve. And with a ray node, I project the perfectly aligned points to that sphere, and on this shape I will just put some jittering so they are not overlapping that much and have some random positioning. Now these two results, so we have the perfectly aligned placement for my Lego bricks, and we also have the scattered version here. I want to save the scattered version into my first version. So I created a VOP network where I'm just going to save out here my points from my second input, which was the scattered one, and just going to create a new attribute called custom position. Something else you could do here as well is you could save out a normal direction. It's not needed, but can be useful if you want to have some sort of direction. So if I enable normal view, you can see that each point will be facing towards where the points will be placed with its random position. Then here as well, I'm going to set a scale attribute just to be sure. So in this case, I scale it by 5. And also just to view it here in Houdini, I created a copy to points, and I can copy these Lego bricks. I also here have a quick VOP that basically blends between those values. So we can see what will be happening in Unreal here as well, just for quick previewing that result. Now everything is set up. What I basically need is just these points with some colors. That's the main information that I want. Then I can use the Niagara node here. And we only need to render only one frame. So here in the timeline, I just need to have one frame because we don't need any animation. I just need one frame of where the points will be. Then also here, I'm going to use a custom attribute, which is called custom position. So later I will show you how we can import custom attributes. So when that is set up, you see the file, have all my attributes. We can just simply press render and go into Unreal. Now here in Unreal, I have loaded in my file, so the Lego pad point cache, and I'm going to create a new particle. So as before, I'm going to go to Effects, Niagara particle, and again, we're going to start here from our Houdini basic particle. So I'm going to add that here, and I'm going to do Lego bad demo. And in here, same as before, we can have to add our point cache file. So we're going to have to make sure we are using the correct one. So what you basically will see now is this, just a bunch of these points. But of course, instead of the points, we want to have our Lego bricks. So let's handle that first. So instead of having the sprite renderer, we are going to use a mesh renderer. So we can replace that by a mesh. So in the project files, I already made one of the Lego bricks. And I'm probably going to have to, as you could see, scale that up. So I'm going to go here to particle spawn, go to mesh attributes, and I would like to control this by one float. And let's start with 5. Okay, 5 was good value here. So now we have that set up. So now we have these bricks nicely aligned as they should be. Now let's start adding the colors. So we can add a color node. So color, we're going to have to open the advanced menu, and we're going to ask our Houdini color. And as you can see, the color is not being applied. So we can see it's still the gray model we have here. So we're going to have to double check the material from my mesh. And the nice thing here is that we can actually override my material. So let's bring in my particle material. So I have material that gets the particle color. So here, particle material, and that works correctly. So as you can see, you have these nice flashy Lego colors. Now, next thing I want to do is I would like to get that custom position. So in my attributes, what I exported here was a custom position. So how are we able to get this in the network? So by default, these sample Houdini point caches, if I go to parameters, they will not include any custom attributes. So if they are not one of these attributes, it will not be imported by default. So what we can do is we can create a scratch pad. So we can type in here, create a new scratch pad module. This will open a new menu here. So in here, we're going to create some inputs first. So here we are inputting certain values. So I would like to have access to my Houdini file, the point cache file. So click on the plus icon, you just type in Houdini, and you're going to use the Houdini point cache file. Automatically here, it will also create these inputs. So you will see that these will also be here. Something else we need is the NID. And if we type in here, we won't see that. And that's because we actually need to create a new integer here. So new integer. And we're going to rename this. So rename, and I'm going to call this an ID. And the last input we need here is the age of the particle. So particle emitter age. So we can ask these values. Now let's make some more room here. So now I want to create some node. And important here is that we actually create a node from one of these outputs, because it will give different results here in the search menu. We're going to make sure we are doing this. So, and then I want to type in get point value at time by string. So this one over here. Then I want to here have the point ID is the NID here, and then also here the age is my time. So then the attribute name here is coming then from what we have here. So we want to have the exact same name, so we can just copy paste this, and we can paste this in here. So I have 1, and I'm going to just do this 3 times here. So we have this for position X, Y, and Z, or in this case 1, 2, 3. And I also want to connect these as well. So now we actually have access to the values, and from this we want to make a vector. So we're just going to type in make vector. And here we can then plug in these values. Now, one important thing here is we actually need to switch the y and the z axis, because here in real, the z axis is the up axis, but in Houdini, the y axis is the up axis. So we need to switch out this information. So that's important to know that we need to here convert that. Then from here, what we can do as well is there probably will be a difference in unit size. So I can multiply this output by 100. So by default, there will be 100 units difference between when you import a model from Houdini to Unreal, there will be 100 units difference. So here, let's place down a multiply node. So multiply. And I just want to have a float. So let's create a float. And I want the float to be 100. So my values will be scaled up 100. You can also decide to scale up in Houdini as well, scale up the attributes, but you can also do it here as well. So you have some room to do it either in Houdini or here in Niagara. Then I want to set a output, and this is a vector. So a new vector, and this is the result of that. And of course, we want to start renaming this to, for example, custom position or scattered position. And I also want to change actually the naming space to a output. And now we are outputting that value. So just important here, we are getting the Houdini files, we are getting the attributes, we are reconstructing some of the attributes, and we are outputting them. So now press apply, and let's go back to our system here. Now a few more things we need to do here back in our system is we first of all need to set here my Houdini cache file, and I'm going to click here the redo. And now let's bring in that Lego pad that I had. So Lego pad file, and here also the NID. We can now use our NID from Houdini. So here, particle Houdini NID. Now let's check if that worked. So let's use a set parameter node, so set existing or directing, and we're going to set the position. So set our main position, and let's see if I can get access to something that is here called custom position. So now I can access here custom position. So let's click that, and this is what you can see here. We have now that scattered version. So next up, I want to talk then about blending the good version with then the noisy version. Also, let's rename this module. So I'm going to rename it, and I'm going to call it get custom position attribute. And we can drag this actually higher up, like so. So we calculate here the point cache files and the attributes, and then we set everything. And what I'm going to do next, I'm just going to actually delete this here as well. And by default, I would actually like to have the noisy version. So here, I'm going to change this from Houdini to my custom. So custom position. So by default, we will have here the noisy version. And now I want to build a blending value or a trigger. So we can first start out with the trigger. And with the plugin installed, we already have a trigger module. So when you go to emitter update, we actually have something that is called a Houdini trigger. So here we have Houdini trigger. So we can use this to trigger the noisy version or the structured version. Now, important here is we need to set some values. So we're gonna have to set the emitter position. So I'm gonna go here and we're gonna just type in position and we're gonna use the owner position. Then we're gonna have to use the player position. So I don't know yet what it is. So what I will do is I will create here a global parameter for the system that I can also access outside of this Niagara system. So I'm going to click here on the plus icon, and let's just create a new vector for the player position. So we will rename this to player position. And now in the trigger, let's use the player position or new value called player position. And further, we can play around here, set the timer amount, for example, to 1. We can also use the timer trigger, and you could, for example, set some more values. So let's start out here, like something like this. And now let's actually use this trigger. So if I look to the parameters, we can actually see here, we can actually see the trigger. So the T5 is called trigger. So this is the one that I want to access. This is the trigger one that I would like to have. So now let's create a new value here. Okay, plus icon. I'm going to do set a parameter, and I want to set the position again. So just going to call position. And now I would like to lerp between two vectors. So here we have our two positions, and I want to blend them between them. So now let's use here our current position, for example. So current position. And I would like then to use my Houdini position. So when the value is 0, we will have the noise. When the value is 1, we will have that structured version. So we can blend now nicely between them. So now let's use that trigger in here, and we're going to have to convert this float into a boolean. So we're going to have to make a boolean from this. And now we can actually link here our trigger. So let's press T5. So T5 trigger. And as you can see, it already returns 1. So a trigger is either on or off. So either the particle is fully reacting to it or it's not reacting at it at all. So let's go and drag and drop this in my scene. So let's drag and drop this in my scene now. And this is the particle. And normally when I set this now to position 0, 0, 0, we will have the perfect version. But when I offset this, you will automatically see that it will go to the noisy version. So this is what a trigger does. It either turns it on or off. So of course, I would like to actually have some more blending. So it actually nicely blends when I move this with my mouse. It nicely blends. So let's go back to our system. And we're not going to use that trigger anymore then, but we will use something else. To create the blending, we need to add a new parameter. So I'm going to go here to parameters, and we're going to create here a new particle attribute. So I'm going to press the plus icon, and this will be a float because this will be the blending value. And I'm going to call this normalized distance to palm. So this is the attribute. And now I want to set that attribute. So we're going to create the set module here. So set. And we're going to use that new attribute, normalized distance to palm. With that, we can use something that is also called distance, normalized distance range. So this will calculate the distance between 2 points. And we can then use our player position. And we can also use our Houdini position over the particle. So Houdini position. And then here the distance will then be, of course, where the blending should happen. So let's try maybe 1000. So that's set up. And then I want to use this then to blur the position. So here, instead of using that toggle here, I want to actually use that lerp. Actually, I want to use my normalized distance. So I'm going to reorganize this a bit. And what you could do is just copy paste this if you want to look back and forth between them. And we're going to reset here the alpha value. And we are going to use the normalized distance to palm. And as you can see now, I think I've reversed the position. As you can see, we are now having the noisy version here, and the good version is out of that range. What we can do with that is, what I also like to do is a curve here. So curve, and our curve value index is actually the normalized palm distance. So we can play around with this curve here to control here, as you can see, that as well. So we can play around with that. So we can do something like that. And we can always afterwards also go back to our distance. And the higher we go, the higher, of course, the distance area of the transition will be. So now let's go back to my scene. So here in my scene, as you can see, we have a nice version that is fully constructed here. And when I will move this particle, we can see that this will go away. So it will break up based on that position. Also, one downside of this construction at the moment is that I hard-coded that position. So as you can see, if I move my mouse to there, I hard-coded this position. So that's something that you could tweak afterwards as well. Now, then the last step would be creating a more interactive with the player. So here we actually have the parameter override parameters with the player position. So right now it's 0, 0, 0. So we only will have the blending transition in the world. So what we will have to do is we need to delete that particle and we need to make a blueprint. We're going to here have a blueprint. And in this blueprint, what I did is I have my Niagara particle, which is that Lego pad. And I also have here then these boxes as my colliders to walk on. Then in the event graph, what I will do is in here, every tick, I will basically send the player position to the Niagara particle. So here you have that Niagara particle, and we're going to set the parameter that is called player position. So what will happen now if I would press play? I will have here these particles going around, and when I come closer, they will build up this area. This is all done in the end with a blueprint. It will bring it nicely together here to make that interactable. So that was it for this video. I hope you enjoyed it, and thank you for watching.